Hey, good morning, everybody. Welcome to week 6. We have made it to the last week that any new work will be assigned. If there's anything else that you need to get done after this week is over, please make sure you let me know. You still have a little bit of time, but don't waste it. This week we're going to talk about the last section, which is 6-6. The notes are going to look a little bit different on my end, just because this is essentially a review section. So we're going to see a lot of things that we've covered throughout the chapter, throughout this at-home learning. So I'm going to go through a few things. It's not going to be a whole lot of writing. I'm just going to be kind of going through the notes that we have as kind of just a recap. Okay. So a couple things is we started off talking about parallelograms. All right. Well, when we talk about parallelograms, there's the basic definition is any quadrilateral that has two pairs of parallel sides. Now, once again, remember the parallel symbol. Parallel is like these little arrows here. Okay, these arrows. So these two sides are parallel. These two sides are parallel. Okay, let me just go ahead and back out of that so it doesn't look disgusting. All right, so a few things, a couple of properties of parallelograms are here. Opposite sides are congruent. So you see these sides here are congruent. These sides are congruent. Opposite angles are congruent. These angles and these angles. Consecutive angles are supplementary. Remember, supplementary means add up to 180. So X and Y, those are all next to each other. X and Y, those are next to each other. X and Y, X and Y. No matter what, X and Y are always next to each other, so they're going to add up to 180. And notice this picture actually works out really nice because these two angles across from each other are both X's, which means they're the same, just like this picture. Y and Y, Y and Y. All right, lastly, the diagonals always bisect each other. They cut each other in half. Okay, so, whoops. So that means this is congruent to this, and this is congruent to this. Okay, so there's just a couple really quick examples just to kind of take a look at. We're not going to go through solving a lot of things, but just looking at some of these pictures. Okay, what can we figure out? So, for instance, here, we have an 8. Well, then, if we know that side is 8, we know that side is 8 in a parallelogram. If this little piece right here is 6, we know those are congruent, so that's also 6. How about this shape over here? This is 70 degrees. Well, if that's 70 degrees, then across from it must also be 70. And then the other ones, how do we figure out the angle next to it? Well, they are supplementary, so 180 subtract 70 leaves us with 110. This is 110. That is 110. Okay, a couple more examples just to take a look at if I can learn how to scroll down. Okay, when you look at this, oh my goodness, I have the same issues I had in the classroom. What is going on? Come on, why can I not scroll down? There we go. Okay, so right here, these angles across from each other, those are also congruent. So we can say that 3x minus 18 is equal to 2x plus 12, and that's how we'll solve for x. Okay, we're once again not going to take the time to go ahead and solve anything. I just want to really talk about setting things up. Okay, same over in example D. These sides we know are congruent. Okay, remember sides are written on the outside more often than not. So we would say 3n minus 15 equals 2n plus 3. Whereas the angles on the inside, the angles are always written on the inside unless it's like these, the last example where there's arrows pointing to it. Okay, those across from each other are also equal. So 6y plus 4 equals 3y plus, I think that was a 37. Okay, you never want to make an equation that's impossible to solve like this. If you went back to this example and you said 3z equals 4y, yeah, those angles are equal, but there's no way to solve this, so you don't want to do that, okay? All right, let's go ahead and move on a little bit. A couple things that we can tell how to prove that something is a parallelogram. All of these are essentially exactly the same that we just talked about. The difference is at this last one, Number 5, if you see one pair of sides that is congruent but also parallel, that tells you it's a parallelogram, okay? So scrolling down to these, we're not going to really spend a whole lot of time. We're just going to go ahead and move through the next ones. All right, we've done examples like those this whole time. Okay, so now we're going to get into a little bit more of the specific ones, and what we're going to talk about is a rhombus, rectangle, and a square. So a couple of things with a rhombus. All of the sides are congruent. Okay? And then opposite angles are also congruent, just like how they were in parallelograms. Rectangles. Opposite sides are congruent, just like parallelograms, but something that's true is all angles are 90 degrees. Okay, so we have a rhombus where all of the sides are equal. We have a rectangle where opposite sides are equal, but all the angles are 90. Okay, so let's take a quick look at the example 1 here. I like this. I like this problem. It says list the quadrilateral for which ones they're true. Okay, both pairs of opposite sides are parallel. Well, that's all of them, right? So parallelogram and everything else that follows, rectangle, rhombus, square. We don't really have the room or the time to list them all, but that's what we're talking about. All right, part B, both pairs of opposite sides are congruent. Well, that's true for a parallelogram. And if it's true for a parallelogram, then it's true for a rectangle, a rhombus, and a square. How about this? All angles are congruent. Now, is that always true in a rhombus? No, because those angles could be all different. How about a rectangle? Yes, because they're all 90. So rectangle, and for that matter, if it's true in a rectangle, it's true in a square. And then how about this one? All sides are congruent. Well, that's not true in a rectangle, but it is true in a rhombus. So it's true in a rhombus, and if it's true in a rhombus, it's true in a square. Okay, let's go ahead and move on. So there's a little bit more now once we start throwing some diagonals in the mix. Okay, in a rhombus, the diagonals bisect each other, which is true in any parallelogram. The diagonals bisect opposite angles, which means this angle is equal to this angle, and this angle is equal to this angle. All 4 of them are the same. All right, all the purple ones are the same, and all of these green angles are the same. Okay? And then lastly, diagonals are perpendicular, which means that even though the picture doesn't look very good, that is a right angle in the middle. Okay, rectangles. Diagonals bisect each other. Well, the diagonals are also congruent, so if they bisect each other, that means all 4 pieces are equal. Okay, for example, if one of the diagonals was 10, the other diagonal would be 10. And if they both split each other in half, that means each of those parts would be 5. For a square, like we talked about, everything is true. Okay? The diagonals bisect each other and all 4 parts are equal. The diagonals bisect all of the opposite angles, which means then, since in a square each corner is 90 degrees, that means each of those little angles is 45 degrees if you divide it by 2. Lastly, diagonals are perpendicular, which means there's a right angles inside. Okay? And we'll do this kind of part at the end here. Oh, right now at this screen. Okay, so a little summary here. Okay, I know it says Unit 9. That's something old that I used. Okay, so don't ignore that. All right, so here goes. We're going to place an X in the box where each characteristic is true. Okay, so it's going to be, oh, hello. So 4 sides. That's true with all of them. Angles add up to 360. That is anything that's got 4 sides. So that is true. for all of these. Now, all of the angles are congruent. In a parallelogram? No. Rectangle? Yes, because they're all 90. Rhombus? No. Square? Yes. And the other, kite, trapezoid, or isosceles trapezoid? That's not true. Okay, how about this? Both pairs of opposite angles are congruent. Opposite angles? Yes, that's true in a parallelogram, which means it's true for a rectangle, rhombus, and a square. But how about a kite? Are opposite angles equal in this case? If you look at the picture above, left and right, yes, they are, but top and bottom, they are not. Nor is it true for a trapezoid or an isosceles trapezoid, because angles across from each other are not the same. Now, when it says only one pair of opposite angles are congruent, that is true in a kite. Okay, and that's the only one. All sides are congruent. All sides are congruent. Which one is that true for? What's going on with this? Come on. Okay, all sides congruent. That's true in a rhombus, and it's also true in a square. So I'm going to put X's in those. Both pairs of opposite sides are congruent. Okay, so that is true in a parallelogram, which means that it's true for a rectangle, a rhombus, and a square. Both pairs of opposite sides are, those little things right there, those mean parallel. So that's true in a parallelogram. It's true in these three. Now it says this. Now this is where things get a little bit different. It says only one pair of opposite sides are parallel. Only one pair. That is true in the shapes. Come on. Why am I having so much difficulty scrolling? My goodness. Okay, only one pair of opposite sides is parallel. That's true in a trapezoid and an isosceles trapezoid. So that's going to go here. You guys will be able to see this better when the notes are saved, but the video is going to be kind of messed up. Okay, diagonals are, that little upside down T stands for perpendicular. So diagonals are perpendicular. That's true in a rhombus, and it is true in a square, and it's also true in a kite. So rhombus, square, kite. I think I did the right one for a rhombus. I guess we'll never know because I can't scroll up. I don't know what's going on. Okay. Oh my goodness. Yeah, I buy this computer to make this easier, and it is not easier. Okay, so last couple ones. Diagonals bisect angles at the vertex. Okay, now that is going to be true in a rhombus, and it's also going to be true in a square. We might not be able to do this. I think something's wrong here. I gotta be honest with you. Let's see if I can go full screen here. Maybe this will make it. Let's try this. Does that work for you guys? No, it does not. I really apologize for the difficulties that we're having. Okay, so where were we? Diagonals. Oh, diagonals are congruent. I guess I missed one. That's true in a rectangle, and it's true in a square, and it's also true in an isosceles trapezoid. Okay, last two. Diagonals bisect the angles at the vertex. That is true in a rhombus, it is true in a square, and that is all. And the last one, diagonals bisect each other. That's true in a parallelogram, which means it's true for the next three. Okay, so once again, I want to really quickly apologize for the way the notes were going for everybody. That was really, really difficult. But that being said, this is the end of our notes, and this is the last time that I'll be talking to you guys for the rest of this school year. So I just want to kind of say that it was a pleasure teaching you guys this year. I wish you guys the best. I hope you have a great summer. I hope you guys stop by and say hello next year. I obviously wish that our circumstances were different, but we're doing a good job of getting through this. Okay, so I want to commend all of you on doing a really good job, and want you to have a nice summer and take care of yourselves. All right, take it easy.